Yo, what up? Today I want to go ahead and talk about the second assignment of the year. For each statement, determine if it is if it is an example of a definition, conjecture, postulate, theorem, or an undefined term. Let's take a look at number 1. All numbers that end in 1 are prime numbers. Well, let's see. Well, we have 1, 11, 21, 31, 41, etc., etc. So this is basically saying, oh, it's a conjecture because it looks like a pattern. So this is going to be conjecture. Number 2, a point denotes a location in space and has no length, width, or depth. So this is just basically giving a definition to a point, but a point really is an undefined term, right? That's one of the undefined terms we talked about in 1-1. So this is going to be, again, undefined term. Here I have if A equals B and B equals C, then A, C. The key words here, if, then. So that automatically tells me that this is a theorem. 2 lines intersect at exactly 1 point. Oh, so I have these lines here and they do some sort of magic. So I'm going to assume it's a postulate. So this is going to be a postulate. Here, a circle is a collection of points that are all equal distance from the same point. Circle is. This is basically dictionary definition. It's describing or giving meaning to that circle, the word circle. Okay, so that's 1 to 5. You can go ahead and complete these problems on your own. Let's go ahead and take a look at number 19 and 27. So it says, write a conjecture that describes the pattern in the sequence. Then use your conjecture to find the next item in the sequence. If I take a look at number 19, okay, I have 1, 1/2, 1/4, 1/8. Well, what is going on in this case? Basically, this is my whole number that is converted into a fraction. Something here is multiplied by something here to give me 1/2, and then something here times something there is going to give me 1/4, and etc., etc. So if I look at this 1, I'm like, okay, 1 times 1/2 is what? 1/2. And therefore, it's going to give me this second term. Now I'm going to take this and I'm going to multiply that by 1/2. So I have 1/2 times 1/2. And whenever you have a fraction multiplied by a fraction, we multiply across. So 1 times 1 is 1. And then 2 times 2 is just 4. And what does that do? It's going to be the third term of the pattern, of the sequence. And lastly, we take this 1/4, we multiply that by 1/2, and that's going to give me 1/8. Okay? So the pattern really is multiply by 1/2, but we are describing the pattern in the sequence. We got to use that conjecture to find the next item in the sequence. So basically it's saying, okay, what is this? Well, I'm going to take that 1/8, multiply that by 1/2 again, so I get 1/16. So the pattern is 1/16. Okay? Number 27, take a look at these 3 squares here. They all have triangles within the squares. So we notice that these shaded triangles stay the same. However, this triangle, if I'm going to take a look at this, if I take a look at this square here, this got moved to the next part, and this got moved to the next part. So for me to describe this, I would say that the second shaded triangle is moving clockwise. And I draw my square, and then I'm going to replicate everything there. So this should get moved to here. Okay, that's the answer. Oh, and we should also shade this part too, because that's the one that stays the same. Okay. Over here, determine whether the statement is always sometimes is always, sometimes, or never true. Two planes intersect in exactly one line. Well, we did see that in 1-1. We had a picture of this, right? So, okay, that's true, but is it always true? If it's always true, we just put always. If it's sometimes true, well, this is sometimes true. Because suppose that I have these two planes, do they intersect? No. So the answer is actually sometimes in this case. So this is sometimes. 3 points determine a plane. That is absolutely correct. So that is always. You need 3 points to name a plane. Let's see. Is there something else I want to go ahead and do? 2 planes are parallel. Are 2 planes always parallel? Sometimes. You can have parallel planes that look like this. These are parallel. But remember, this is true. I can give a counterexample to that, which is this. So sometimes. And then I'm going to give you this one. You're just going to have to believe me for this one. This requires you to, understand more math. You have to get into like a higher level math to understand what these mean. Again, this stuff is just for you to essentially be familiar with, because we'll present you with these words, but we don't expect you to like know everything about this in this course. Just be aware that this exists or these exist. So we're just going to go ahead and put sometimes. Okay? And hopefully the homework help is actually helpful. Again, if you have any questions, go ahead and let me know. All right, I'll see you next time.